Hey guys, sorry I missed you today. Today we're going to look at the topic of more similar polygons. So we're just adding to what we did yesterday. So what I need you to do is grab a pencil and get ready to take some notes. First, we're going to start with the definition of a common ratio. A common ratio is the ratio of the lengths of two corresponding sides of similar figures. So if I was to have a triangle, and another triangle, and this side was 3, let's say on triangle A, B, C, and then we have triangle D, E, F. Side DE is equal to 5. You have 3 and you have 5, which are the corresponding sides AB and DE right here. So the common ratio from the side lengths would be 3 to 5. So let's say this one was 6, this would be 10. Again, the common ratio is 3 to 5. And we could break that down because we saw from yesterday that 3 over 5 is equal to 6 over 10. So let's look at example 1. It says use the similar figures below to answer the questions that follow. What is the common ratio of quadrilateral ABCD to quadrilateral EFGH above? You can take any one of those sides. Here I'm going to take AD and EF because those are the ones that correspond. So we want the ratio of ABCD, which is this figure right here, to the quadrilateral EFGH, which is right here. So we'll take this number, 10, put it over this number, which is 5, because those are the corresponding sides. But what is equal to 10 over 5? That equals 2 over 1. So actually our common ratio here is your simplified fraction, 2 over 1. The next thing says show that the ratio of the perimeter is the same as the common ratio. So let's find the perimeter of each figure. 10 plus 8 is 18, plus 6 is 24, plus 5 is 29. So that's the perimeter. 5 plus 4 is 9, plus 3 is 12, plus 2.5 is 14.5. Let's look at this. 29 divided by 14.5 is the same thing as 2 over 1. So that common ratio is the same thing from side lengths and perimeters. Now let's look at it if we were doing the common ratio from quadrilateral EFGH, which is the smaller one, to quadrilateral ABCD, which is the bigger one. All we have to do, we can take 4, put it over 8, 4 over 8. So the common ratio here is 1 over 2. If you'll notice, the first example, or the first part of this example we did, went large to small. This one went small to large. And that's what gives us the difference in those fractions. Example 2. Determine if the figures are similar. Justify your answers. The way that we can work similar figures or similar polygons is doing small over large is equal to small over large. And see if that works, if I can spell. So first we'll take the small, which is 6, put it over 9. So we have small over large to its corresponding part. Let's see if that equals our small over our large. 2 over 3. And remember from yesterday, to check and see if something is proportionate, we cross multiply. So 9 times 2, we want to see, does it equal 6 times 3? 9 times 2 gives us 18. 6 times 3 also gives us 18. So yes, these figures are similar. Example 3 says use the similar figures below to answer the questions that follow. Quadrilateral EFGH is similar to what quadrilateral? EFGH is this quadrilateral right here. It is similar by matching up the angles to A, B, C, and D. What is their common ratio? To find the common ratio, we're going to look at the two sides that we actually have values for. And that would be side DC and side HG. And since our similarity statement goes from large to small, we're going to write our common ratio in terms of large to small, or large over small. Remember yesterday we started by writing the words first, so if you would like to do that, go ahead. So now let's look and try and find our common ratio. We have side HG and we have side DC. Our large is 10. Our small is 2.5. When we have a fraction, we don't like it for there to be a decimal on the bottom. So what we can do is we can go ahead and simplify this fraction. 10 divided by 2.5. If you put that in your calculator, you'll get 4 over 1. So our common ratio is 4 to 1. What that means is for every 1 unit in this triangle, not this triangle, this quadrilateral is an extra 4 unit, or is 4 more unit, 4 times as many units. So now that we have our common ratio, we can use the common ratio to set up a proportion to find the missing side values, x, y, and z. Let's start with x. Start by writing down your common ratio, 4 over 1. Now we'll set up our proportion. X is the small, it goes on bottom of our fraction. 12 is the large, so it goes on top. So I have 4 over 1 is equal to 12 over x. If we cross multiply, we get 4x equals 12. When we divide by 4, we get x equals 3. So our x value should be 3. Now let's find the y value. Start with your common ratio, 4 over 1. Then we're going to look for y. Y is at FG. It corresponds to BC. Remember, it's large over small, so this will be y over 3. Again, we cross multiply, then we'll divide if we need to. 4 times 3 is 12. 1 times y is y. So our y value is equal to 12. Now let's find the z value. Again, start with your common ratio, 4 over 1. Now, our z is at AB. It's our small side. It corresponds to side EF. So 4 over 1 should be equal to our large side, which is 5, over our small side, which is z. 4 times z is 4z. 1 times 5 is 5. We would divide both sides by 4. So we have z is equal to 1.25. The next question asks us what is the ratio of their perimeters. If we add their perimeters together, 10 plus 12 is 22, plus another 12 is 34, plus 5 is 39. The perimeter of ABCD, 3 plus 3 is 6, plus 2.5 is 8.5, plus 1.25 is 9.75. If we set up a ratio of their perimeters, large over small, we would have 39 over 9.75. When you put that into a calculator and you reduce it, that's 4 over 1. So the ratio of the perimeters shows to be the same thing as the common ratio. Example 4. Use the similar figures below to answer the questions that follow. Find the common ratio of polygon RSTUV to polygon ABCDE. Again, we're looking at large to small. So we're going to have to do 18 to 4. 18 over 4. We can reduce both by 2, which would give us 9 over 2. So our common ratio is 9 over 2. Now it asks us to find the values of x and y. We have to write our proportions. Start with your common ratio, 9 over 2. Let's find x first. RV corresponds to AE. Remember, we're doing large over small, so it's going to be x over 3. We'll cross multiply and divide. 9 times 3 is 27. 2 times x is 2x. Divide both sides by 2. So x is 13.5. Now let's find the value of y. Again, set up your common ratio. 9 over 2 is equal to our large side, which is y plus 2, over our small side, which is 5. Here is where we cross multiply and divide. 9 times 5 is 45, and that is equal to 2 times y plus 2. Don't forget that when we have this, we have to distribute to both things. So we have 45 is equal to 2y plus 4. If we subtract 4 from both sides, we get 41 equals 2y. Divide both sides by 2. and y would equal 20.5. Let's look at example 5. Quadrilateral ABCD, which is the small one, is similar to quadrilateral EFGH below. Answer the following questions. The measure of angle E would be equal to the measure of angle A, so it would be 60 degrees. Because remember, corresponding angles are congruent, and you also have to remember that corresponding sides are proportional. So let's go ahead and find the angles. This one's 60. We know that G and C are both 90, so if measure of angle G is 90, the measure of angle C is 90 degrees. The measure of angle B corresponds to the measure of angle F, so it is 100 degrees. The measure of angle H and the measure of angle D would both be 110. This is because all angles inside of a quadrilateral add up to 360 degrees. So now let's find the measure of side EH, BC, and AB. In order to do this, we have to set up a common ratio. We're looking at small over large, so we can take one side of the small, let's take DC, and set up a common ratio with one side of the large, HG. This would be 6 over 18, which is 1 over 3. So our common ratio is 1 over 3. So now let's find the measures of EH, BC, and AB by using a proportion. First, start with your common ratio. 1 over 3 is equal to, let's find EH first. EH corresponds with AD. So our small side is 5. Our large side, I'm just going to name X. If we cross multiply, 1 times X gives us X. 3 times 5 gives us 15. So EH should be 15. The next side it asks us to find is BC. It corresponds to FG. We will set up a proportion. Start with your common ratio. 1 over 3 is equal to our small, which we don't know, so I'll name it Y, over our large, which we do know, that is 9. 1 times 9 gives me 9. 3 times Y gives me 3Y. If we divide both sides by 3, that means Y is equal to 3, so BC equals 3. Lastly, let's find AB. AB is the small, so again we'll have our variable on top. EF is the side that it corresponds to, and that is 21. I'm going to show you a little bit different way to solve this. What's your common ratio? It's 1 over 3. I'm going to go ahead and name side AB Z, just to give us a one-letter variable, and that is over 21. What do I multiply 3 by to get to 21? Yes, we multiply by 7. So what would I have to multiply 1 by to get to this one? 7. So 1 times 7 would be 7. So our Z value is equal to 7. Works out the same way if you do cross multiplication, because you would have 1 times 21 and 3 times Z. Divide by 3, and 7 is equal to Z. Example 6. The lengths of the sides of a triangle are in the ratio of 3, 5, and 7. Its perimeter is 120 centimeters. Find the lengths of the shortest side of the triangle. Here you have your proportion, and we know what our side lengths are, but they're unknown. So what we can do is say 3x plus 5x plus 7x equals 120, because we add all the sides up to get a perimeter. 3 plus 5 is 8, plus 7 is 15. So we have 15x equals 120. Now we divide 120 by 15. And we get 8. So our x value is 8. And what you'll notice, it says find the length of the shortest side. The shortest side of that triangle is the 3. So 3 times 8 would give us the length of that shortest side. 3 times 8 is 24. Example 9. The measures of the angles of a triangle are in the ratios of 1, 2, and 3. Find the measure of the largest angle. We know that all angles inside of a triangle add up to equal 180. So if we go ahead again and use x, 1x plus 2x plus 3x, those come together to equal 180. 1 plus 2 plus 3 is 6. So we have 6x equals 180. Divide both sides by 6. X would be equal to 30. Now our question asks us to find the measure of the largest angle. The largest angle is the 3, the part of the ratio that is 3. So we would say 3 times 30, because it's our 3x part of our equation, and get our value for the largest angle. 3 times 30 is 90 degrees. That concludes our notes. Now what I need you to do is get to work on your assignment. You may help each other with your assignment, but please do not cheat and copy off each other. You need to show your work on each problem. I hope you'll have a good day, and I'll be back tomorrow.